All right, so I'm going to walk you through a position, velocity, acceleration, total distance, speed, speeding up, slowing down type problem. We've done this one before. We didn't work this one out together. I'm going to work through number 18 from start to finish. So notice we got a polynomial here. That's awesome. These are all the questions we're going to answer. Find the velocity and acceleration. Find the position, velocity, speed, acceleration at time t equals 1. That'll be just plugging in. Super easy if you've got the correct functions. And at what times is the particle stopped? That's when the velocity is 0. So we'll find the velocity, set it equal to 0, and find the times that makes that happen. When is the particle speeding up or slowing down? We're looking for same signs on velocity and acceleration, opposite signs on velocity acceleration. And then find the total distance traveled by the particle from time t equals 0 to time t equals 5. We'll be using some absolute value. We'll be adding up little segments. All right, let's go ahead and get started. So number 18, I've already written it down over here. We've got t to the 4th minus 4t squared plus 4. First thing is to find the velocity and acceleration. So for part A, let me go and zoom that out a tiny excuse me, tiny bit. So velocity, as a reminder, is simply the first derivative of position. Now you don't really need to write this part right here, but if you do, that's fine. But I do want you to write velocity, all right? Let's get that nice notation going every time. So the derivative would be 4t to the 3rd minus 8t plus nothing, and we're done with the velocity. Let's go to the right, and we'll find the acceleration, which is simply v prime, also known as s double prime. And I may run out of space here. Let me see if I can squeeze it in. That would be 8t squared minus 8. All right, there we go. So we got, oh, I don't know how to multiply apparently. Can I get an it's cool? Thank you. There should be a 12t squared because 4 times 3. All right, so we got our two derivatives, and exactly what I was telling you a moment ago, make sure you're careful with your derivatives because plugging into those derivatives or velocity and acceleration functions, if they're not correct, obviously, it's not going to go well. All right, so velocity is done. Acceleration is done. It's time to do part B. Find the position at 1. So we're going to go into our position function, which is right up here. We're going to plug in a 1. We're going to get 1 to the 4th minus 4 times 1 to the 2nd plus 4. I'm going to fast forward here. That's a 1 minus 4 plus 4. These will cancel out. You get a 1. Next up, they want velocity at 1. So we'll go over here. We'll say 4 times 1 cubed minus 8 times 1, which is 4 minus 8, which is negative 4, which means moving to the left. Nobody asked for that, but moving to the left at t equals 1. Nobody asked for it, but if they do, or if you needed to know, there it is. Next up, the speed, also known as the absolute value, is simply the absolute value of what you had there for the velocity. So that's going to be a 4. And I guess the units were given in this one, so that would be feet per second. I should put that on there, and this is also feet per second. Okay, last one on this part B is the acceleration at 1. You're simply going to plug in the 1 again. Don't overthink this. You plug into the functions and go, go, go. 12 minus 8, which turns out to be 4. Since it's acceleration, it'll be feet per second, or feet per second squared. All right, I think we're done with part B. Let me double check. Position, velocity, speed, and acceleration at time t equals 1. Very good, we are done. Next, part C. At what time is the particle stopped? Well, that means when the velocity is equal to 0. So we're going to take our velocity. I'm just going to copy it down from right up here. I'm going to set it equal to 0. And then I'm going to factor out a 4t if I can. Good. T squared minus 2. Ew. All right, I was hoping for a 1 or a 4 or a 9 or any perfect square, but oh well. Oh well. So that means we get t equals 0, and this is t squared minus 2 equals 0, so t squared equals 2. Please don't forget it's a plus or minus on that. It turns out we're only going to want the positive version. because they mention it up here, time has to be positive or not negative. So I guess we're pretty much done. We just need to say this: velocity is 0 when t equals 0 and t equals rad 2. There we go. So drop the negative. Okay. All right, so that's it for part C. Next up, part D. When is the particle speeding up and when is it slowing down? Well, we have the velocity 0 out times. We need to do the same thing for acceleration. In other words, let's get some critical values for acceleration. It was 12t squared minus 8. Set that equal to 0. We're going to factor and solve. Or solve any way you want to. That's fine. In fact, I'm seeing another technique. If I just go 12t squared equals 8, and then t squared equals 8/12, also known as 4/6, then I could say t equals plus or minus 2 over square root of 6. And we do not need to rationalize. We can leave it with the radical on the bottom. So that means we'll focus on just the positive version there, for the same reason we focused on the positive version of time for velocity. All right, now that we have both of those, we're going to want to put those together on wiggle graphs. So I'm going to go down here. Maybe I can use this space right here. Let me get the lights turned back on. Hang on a second. All right, we're back at it. So let's put velocity on this first one. And I like to leave a little bit of space. We'll go down a couple of lines. We'll put acceleration on this one. And keep in mind, we need the 0 mark. So t equals 0 here. And let's see, the other critical point for velocity was square root of 2. We're going to ignore the negative versions. Next, we're going to go down here. Well, I'm looking at my notes here and I had a different answer. Did I mess up again? Oh, I see what it is. I could have made this a 2/3, which means down here it would have been plus or minus square root of 2/3, which, if I were to rationalize, we'd have a rad 2 over rad 3 times rad 3 over rad 3, which is rad 6 over 3. I'm just wondering if I messed this up. Let me check this one here. 2 over rad 6 times rad 6 over rad 6, which is 2 rad 6 over 6, which is rad 6 over 3. Okay, we're fine. You can use either form. This is a simplified radical, and so is this one right here. So either one of these, if you rationalize, you'll end up with the rad 6 over 3. I'm going to leave the 2 over rad 6. Okay, so I'm going to go to 2 over rad 6, which excuse me, I believe is in between these guys. Let me make sure of that. Let's see, 2 divided by rad 6. Rad 6 is going to be bigger than 2, smaller than 3. Bigger than 2 because square root of 4 is 2, right? I'm thinking of square root of 4 and square root of 9. So bigger than 2, smaller than 3. So if it's bigger than 2, this fraction will be less than 1. Okay. And it's not too tiny though, because this is only a 3 over here, or less than 3. So I'm thinking we're fine to say right between here. That's a little tricky sometimes, but you can do it. Just think about the numbers. You're estimating, obviously. All right, so it's time to go figure out what's the velocity in here, what's the velocity out here. I know the velocity is 0 there and there. I know the acceleration is 0 there. Let's go ahead and plug in something in between 0 and rad 2. How about 1? That works for me. We're going back to our velocity, remember. So we'll go over here. You can go to the factored form or non-factored form. Doesn't really matter. In fact, do you already know the velocity at 1? Yes. We already know it's -4. So that's a negative in there. I like to put multiple negative signs because we're going to be circling some stuff. Next, bigger than rad 2. And there are no other critical points to the right of that. So bigger than rad 2, like 2 or 3 or 5 billion, whatever, it'll do the trick. So put in a 2 or a 3 or 4, you're going to get this is bigger than that. How about 2? That'll be an 8 times 4 is 32. 32 minus 16. Definitely a positive. All right, so we're looking good. So next up down here, we're going to go left of 2 over rad 6 2 over rad 6. Let's go plug in 0, because there are no other critical points besides the negative root 2 over root 3. So if you just go to 0, you're safe. You plug in 0, you're going to get a negative. And then go to the right. Let's see, bigger than 2 over root 6. And there were no other critical points to the right of 2 over root 6. So you can plug in something big, like 10. And you'll see that that's going to be positive. Okay, plug in 10. You get a huge 1200 minus 8. That's positive. All right, it's time to go circle some sections. There we go. Same sign, speeding up. Opposite sign, slowing down. Same sign, speeding up. Therefore, we will say V and A, let me zoom out so you can see the big picture here. V and A have same signs. So speeding up on 0 to 2 over rad 6. And out here, which is, what was that, rad 2 off to infinity. So there's the speeding up. And then we'll say V and A have opposite signs. So slowing down on this one little interval in between. And that would be 2 over rad 6 all the way to the rad 2. All right, we have our intervals for speeding up and slowing down. All right, next up is part E. Part E is to find the distance traveled, the total distance traveled. Now what we'll need to know is, excuse me, when did it start, when did it stop? And they gave us an interval. They gave us this right here, from 0 to 5. But we also know that it turned around once in there. We saw that on our wiggle graph over here. It went from a negative velocity to a positive velocity. So we're going to use 3 values here. We're going to use s of 0, s of rad 2, and s of 5. Now we're going to calculate each one of those. S of 0, super simple. In fact, let me bring the position function down here so I don't have to keep sliding the paper. Almost done, guys. Hang in there. All right, so plugging in 0, it's an obvious 4. Plugging in a rad 2, and I believe we did talk about this one in class. We have this one in your notes. So rad 2 times rad 2, that's a 2, and do it again, that's another 2, so that's going to be a 4. This is a 2 times a 4, which is minus 8, and then plus 4. So if I'm seeing this correctly, it's a 0. That's odd. That doesn't happen every day, but it is what it is. Next up, plugging in 5, we get 5 to the 4th, minus 4 times 5 to the 2nd, plus 4. I'm going to fast forward here, that's 625, minus 100, plus 4, which turns out to be 529. If these numbers look familiar, it's because we've done this. You can check your notes. 18E. Total distance is s of rad 2 minus s of 0 plus, do it again with the other two. So we grab these two together, and now we're going to grab these two together. So time started here. We started keeping track of the distance here. It turned around here, so we're going to stop measuring distance for a moment, calculate that. That'll be here. And then it's going the other direction now, from rad 2 to 5, and the other direction meaning to the right. It says so right here. And we're going to calculate that distance until we get to 5, because that was the stopping point. Now, it's not necessarily at rest at 5. That's not what I'm saying. But I'm saying they told us to stop keeping track of the distance. Okay, as in like the runner crossed the finish line and kept on running. We stopped measuring how far he ran at 5. Okay, so we're going to go s of 5 minus s of rad 2. And we're simply going to plug in now. 0 minus 4 in the first absolute value. That doesn't look like an absolute value. And then the second one, we're going to have 529 minus 0. So we'll get 4 plus 529, which is 533 feet. Lovely. All right, that's pretty much it. I guess the only other thing we could do, if you needed to, if this makes sense to you, I don't think I'll ask you to do it. Let me rephrase that. I will not ask you to do this on the quiz, but if this is a position axis, we could talk about how the position is 4. If this is 0, it starts at 4, we'll say. And then from time 0 to time rad 2, it's moving to the left. And its position, when we get to rad 2, is actually 0. So it starts here, it goes left, and then it turns around. And it's just going to keep on going to the right. You can see that with the positives out here that don't stop. So this right here is the turnaround point. And this is definitely not drawn to scale. This is t equals 5, and that's going to be 529 on the axis. So if you were to just kind of mark this off, go, well, 4 back to 0 is 4. And then from 0 out to 529 is 529. You're going to get exactly what we got, 533. This can get a little more complicated when it goes back and forth multiple times, but there it is. There you have it. Position, velocity, acceleration. This is a fairly straightforward one because of the polynomial status. You should practice some other ones that maybe have a rational function like a t over t squared plus 4 or something like that. Maybe some other types of problems as well. All right, see you later.